Hello students, today we will discuss bisection method in this video. So this method is used to find the solution of a given equation. Suppose that we have given an equation f of x is equal to 0 and we have to find the solution of this equation, right? So suppose that we will consider two value a and v such that f of a into f of v is less than equal to 0, right? If this condition is hold, so how we will get the graph of this function? Suppose that this is a f of a is a positive value, mean suppose that this one is a, this one is b, and f of a is this one, right? And if this is less than equal to 0, it will be strictly less than 0. It must be strictly less than 0. So this f of a must be negative. Suppose that this one is here, this is f of v and this is f of a, right? So how will be its graph will be something like this, right? So this this point is called 0 of this equation. Suppose that this point is c, then f of c is equal to 0. Hold this equation, right? So this we have find this one, so we will find one more point, and suppose that that point is c1 is equal to b minus a divided by 2. So it will be at the mid of a and v, right? So we will find in another further step f of a dot f of c1 and f of v dot f of c1. One of them is less than 0 and one is greater than 0, right? If this we have considered that f of a is greater than 0 and f of v less than 0, so if it is less than 0, this one is positive, so it must be negative. It must be negative, right? And in this one is negative, and if it is greater than, then it is also negative, right? So from here our solution will be between a and c1, because this one condition is hold, right? So solution is between a and b. Then in further step, there exists a point c2 between a and c1 such that c2 is equal to a sorry c1 minus a divided by 2. In this same step we will perform same method. F of a we will find f of a dot f of c2 and f of c1 dot f of c2, right? 1 is greater than 0, 1 is less than 0, or less than 0 or greater than 0, right? So if it's less than 0, then solution will be exist here between A and C2. Less than 0 imply solution between A and C2, right? If this is less than 0, imply solution between C1 and C2. In this method, our Ci will tends to our solution. It will not be a exact solution, it is approximate solution, mean we are trending toward our actual solution. So this was the method, bisection method, and if we will consider one example, suppose that we have given example f of x is equal to x square minus 2, and we have to find the solution. Solution is what? So suppose that we will take 2 point, x is equal to 1 and x is equal to 2. F of 1 is equal to minus 1 and f of 2 is equal to 2. F of 1 dot f of 2 less than 0 implies solution exists between 1 and minus. Solution is between 1 and 2. Then in next step what we will do, we will perform. So we will find, suppose that x1 is equal to 2 minus 1 upon 2 is equal to 1 by 2. Sorry, we have to add, so we will perform some correction here. So we'll perform some correction here. So this is 3 by 2. We will also change this minus here to plus. This is plus, right? And this is also plus. And now we will find the value of f of x1 is equal to 3 by 2 square minus 1, sorry 2, is equal to 9 by 4 minus 2 is equal to 9 minus 8 by 4 is equal to 1 by 4. It is greater than 0, and f of 1 dot f of 3 by 2 is equal to minus 1 into 1 by 4 is equal to minus 1 by 4 less than 0. So solution exists between 1 and 3 by 4, sorry 3 by 2. So in next step we will perform same thing. So x2 is equal to 1 plus 3 by 2 by 2 is equal to 2 plus 3 by 4 is equal to 5 by 4. So x2 is equal to 5 by 4 and f of x2 is equal to 5 by 4 square minus 2 is equal to 25 by 16 minus 2 is equal to 25 minus 32 divided by 16 is equal to 25 minus 32 is equal to minus 7 by 16. So f of x2 is less than 0 and f of 1 is less than 0 and f of x1 greater than 0 imply f of x2 dot f of x1 less than 0, right? Imply solution exists between x1 and x2. Here x1 is equal to 3 by 2 and x2 is equal to 5 by 4. In next step we will perform same thing. So x3 is equal to x1 plus x2 by 2 is equal to 3 by 2 plus 5 by 4 divided by 2 is equal to 6 plus 5 divided by 8 is equal to 11 by 8 is x3, and we will perform same thing. We will find f of x3 and in is equal to something, and in next step we will find the value of x1 dot f of x3 and f of x2 dot f of x3. If one suppose that this value is less than 0, then solution will exist between x1 and x2, between x1 and x2, and in this solution we will tends to our solution. And we know that what is the actual solution of x square minus 2 is equal to 0 is equal to imply x square is equal to 2 imply x is equal to square root 2 it, and what is the value of square root 2? And it is approx 1.41. So our solution will tend to this one, right? And it depends on us that how accurate we have to find the solution. So we will perform more and more iterations. So this is actually a iterative method. So what we have performed in this question, in this method, so it what was the bisection method? Bisection method was a method to find the solution of an equation. It is an iterative method. In this method we will find approximate solution of given equation, right? This was the equation. And what was our next step? We have to assume 2 points such that f of a and f of v into f of a into f of v less than 0. Okay, so it confirmed that there is a point in which f of x vanishes, right? So there must be a point c such that f of c is equal to 0, but we don't know that what is this that point c. So we consider one another point. Suppose that this is c1 is between a and b. It is a midpoint of a and b, right? So it was a plus b by 2, and in next step we find same thing, f of a dot f of c1, and if this one is less than 0 imply there is a point such that f of c is equal to 0 mean there is a point between a and c1 such that f of c is equal to 0 if f of a dot f of c1 is less than 0, and if f of v dot f of c1 is less than 0, then there must be a point c such that f of c is equal to 0 is between b and c1. So we perform same thing and find more and more iterations, and these iterations give us solution, and we will change to our actual solution. We will not find exact solution, but it depend on us that how accurate we want to find. It may be after we can find exact after 3 point 4 point. It depend on our iterations, right? Okay, thank you.